This is my first time working with cartoons at Mac.
Hello, I'm Angelica Heaney. I'm a dual major computer science and mathematics major. This is also my first time working with Arduino, so. What are my hobbies?
No.
What are my hobbies?
No. Continue.
Okay, so our project is called WitEBoard. The idea came from Chris Finn. He's our team captain, but unfortunately he isn't able to be here with us tonight. So we're presenting our project, and what our project encompasses is we're looking for a better way to implement a whiteboard or as a smart board. Because smart boards are really expensive, and what we've been trying to come up with was to figure out a way to be able to capture images onto a computer using ultrasonic sensors. And by doing that, we'd be able to capture like certain images. And we emulated a marker which would have a gyroscope, but we didn't have enough time to put that on. That would follow the movements of what it would do. So to give a demonstration on the laptop. So we weren't able to calibrate it perfectly because we didn't have enough resources for the ultrasonic rangefinders. So we had to use triangulation in order to measure our distances. So we would be able to draw from to the left and to the right and up and down. So it's like Etch-a-Sketch right now, but with more ultrasonic rangefinders, we'd be able to create a much finer sketch, and eventually that'd be able to turn into something that would be usable. So not only can this be placed on a whiteboard, but it can also be mounted like on a table. So it's because a lot of people they want to write, like some people aren't comfortable with writing on a tablet because it's glass and the stylus doesn't feel as right. So by using something like a marker or something like this, so we had a transmitter that would ping a signal to two receivers that would take the signal and process it in our code. And I worked on the processing of the signals, and Angelica worked on the PHP aspect.
So basically this just sends the coordinates of wherever that's supposed to be to, like it submits it into, I've got a database on this thing running it on Apache 2 server because I really like Apache. And then all it really does is just translate those coordinates on the paper. It's real simple actually. I think it's a pretty neat idea. Pretty good applications. You can basically turn any surface into a whiteboard with this. It might be good in low-income areas. I don't know how much a whiteboard actually costs. I haven't looked into that, but I'm assuming it's going to cost more than $40.
So the parts that were found on this, you can actually find it on eBay for about $40 or less. So it makes for a very, very economical way to do this. And the sensor problem, Chris Finn actually found the sensors for about $1 per sensor. So it'd only be like $50 for a whole grid of sensors that would allow for a good XY tracing for the supposed whiteboard or makeshift whiteboard that we have. And also, I think we'd like to also thank the mentors and sponsors here because they've provided like a lot of help to us. Like we were stuck on a lot of problems. I was stuck on the Arduino problem, and I had a lot of mentors that have helped me through that. And yeah, so are there any questions?
How does the triangulation work, or how did you figure out how to do that and implement that?
Actually, do you want to come up here and take a look at our code?
Maybe just briefly explain it.
Okay, cool. So basically, it just uses arc cosine to find the angle. Imagine you have a point here and here is mounted, and say you get a signal from about here. You use arc cosine to find this angle, and then basically all I did was I took the length from here to here because it was given to me as distance from the transmitter to the receiver. I set that up as a line from here up the y-axis, and then I just put it through a rotation matrix to print side rays.
This is also, you came up with this originally, correct?
The mathematics,
Well, not the math, but I mean like this is like the application of taking this and then applying that, right? Okay.
Does the marker know when it's being lifted off the surface?
So what we were planning to implement was to put the gyro on it so that we could lift it off. Another way to do it would be like, so the rangefinders would like ping, so this would transmit, and this would receive, and if nothing was transmitting, it would automatically receive a ridiculous amount of length, like 500 inches. So we could implement it where like if both rangefinders did not see it, then it wouldn't drop. We were under a time constraint when we realized this. So
when you mentioned the cost of the components, would that be a wired cost like you showed, or you mentioned a wireless solution?
So Chris Finn mentioned, or we tried to implement, I think, an RF chip, which had like a 443 megahertz frequency that, but it didn't work out. We spent a few hours trying to do that, but the frequencies weren't matched up, or like we weren't able to match up the frequencies that, and it just wouldn't, like the sensors just wouldn't read our ping wirelessly. So we could work on that in the future, but yeah, eventually it would be able to make that cost even as a wireless